Yep. So it's yeah, it's been good today. Did you see the announcement about global integration, global Azure?
Yes, well, I was part of the announcement. Yeah.
Yep. I figured you were.
Yeah, we were talking about it last week actually before Summit. So
Yeah.
we've actually had a few people from Europe contact us and say, "Oh, look, we just can't do this day. We just can't do it." So yeah, we spoke with the guys at Microsoft.
Oh.
Yeah, it was all good. Yeah. So.
Yeah. So what I was thinking, since this is working as good as it is, we might be able to do a local online version.
Yeah, that'd be good. I know there is some talk about maybe finding some online version that we can do. I know we're talking about that internally, but I don't know really what shape that will look like. But if we've got the speakers and everything here, then absolutely we could do that.
Because I mean, the biggest thing is going to be time zone, and if we do one local for Australia, New Zealand.
Yeah, correct. And in fact, most of Asia as well would be interested in that.
Yes, and
language aside.
And that seems to work good because I'm using Zoom.us for the meeting, but it's got a feature that streams it out to YouTube.
Yeah, I can see this is live on YouTube now. It's really cool.
Yes. So it doesn't matter. Like I was worried I had 100 licenses if we got a bunch of people on, but the fact with YouTube, you can just push them over to YouTube and it's not a problem.
That's very cool.
So, okay. So we got a few people coming in. We'll give them a couple more minutes and then we'll get started.
4 participants so far. Attendees 3. Oh, I see. Cool. That's very cool.
Yeah, this is we moved over from GoToWebinar to Zoom.
Yeah, I mean, yeah, that GoToWebinar was okay, but this seems to be a slightly better experience, I think.
Yeah. So, and the fancy little box I got here, I'm going to play with on my talk.
Aha, nice.
I've got the little Roland video mixer.
Nice.
Well, it's going to be great for the in-person event because it takes 3 HDMIs in. So the speakers, laptop, and then 2 cameras.
Okay, so you can. So what's that? So that allows you to then mix stuff directly into the subscription channel.
Into the stream, yep.
And swaps in it. Very cool.
And Zoom supports it as a input camera.
Oh wow.
So input camera and input audio. So.
What's that box? Can you send me any details of that? Because that's quite interesting.
Yeah, so I got them. It's a little pricey. It's about $1,800.
Okay.
But I got them. They sent me a demo one to use for the weekend.
Oh, very sweet.
Yeah. Nice. Okay, so we got 3 attendees on there right now, but other people will join, and some people may be joining on the YouTube. I will let you share your screen, and we will get started.
So let me share my entire screen, which is that there. Share. Let me know when you see it.
Yep. It is there. So, cool. And basically, over to you. Introduce yourself and have a go.
Oh, here we go then. Right. Let me just start my presentation. There we go. Cool. So I guess, can you see that, Bill? Yeah?
Yes, everything's fine.
Cool, fantastic. Right, so thank you, Bill, for inviting me to present today. Great that we can do this as a remote event, given current circumstances. So I'm actually based in Perth, so for me, it's if anybody's over here, I'll say good morning. For everybody else, I'll say good afternoon. I'll be talking about event-driven microservices with Azure Functions, Events Grid, and Cosmos DB. Now, just a very quick intro to me. That's me smiling with my great beard. So I'm a Microsoft MVP for Azure. I'm also actually, as of last year, a Microsoft Regional Director. You may or may not know me as one of the administrators for Global Azure. We've called it Global Azure now rather than Global Azure Bootcamp. Reasons for that will become clear at some point. I help Bill and others out for the Global Integration Bootcamp, which we're on now, of course. Partly help Bill out when I can with Integration Down Under, and then there's a bunch of other stuff there as well. So we shall move on. So my agenda today really is really this. So you've probably got a clue as to what the agenda is, given the title is basically this. So we'll talk about generally sort of microservices architecture, bit of a conversation around functions, event grid, and Cosmos DB, and then really we'll talk about the scenario, which is probably the more interesting stuff in terms of what we're going to be doing, and then a demo. So we've probably all built one of these. This is a typical multi-tier architecture that we've probably been building for the last however many years. I've included some pros and cons there. You've probably got your own, but for me, I think a key one here is that whilst it does impose a degree of separation of concerns, you can create services. If we think back to our old days of service-oriented architecture, we may well have services that are very specific to doing a particular task, but quite often you'll find that there'll be a monolithic data layer below that all writes back to a very, very standardized approach in terms of databasing around a relational database. So there is separation concerns in places, but not everywhere. So low service orchestration, what do I mean by that? Well, essentially you don't really need so much of it because the orchestration is really happening in the UI layer. So the UI is kind of calling the services, bringing all that data together and pushing it back out again. The services may themselves call the other services and so on and so forth, but there's not much orchestration that's required in terms of messaging between them. And from the perspective of testing, of course, easy-ish to test through inversion of control, but noting that you have to do things like mock out the huge data access layer in the front end and so on and so forth. So your mileage may vary in terms of how well you actually do that. The big cons, for me at least, is really you're still building a monolith. It may look like it's not a monolith, but it really is. And it's still a monolith because you still have that tight coupling between the layers. So if you've got that monolithic database at the back and you've got a data access layer that evidences that back up through some kind of ORM that's then used across all your services, essentially you've got tight coupling, because it means that every time you change that data access, you have to publish those changes to everything that needs to care about it, which of course means that it's difficult well, your internet connection is unstable. Thank you, NBN. Which means it's difficult to change. Change is a big bang change, and it also means it's very hard to scale because you can't scale things in separate little chunks of scale units. So, what does microservices architecture give us? So, a much clearer separation of concerns, because essentially, and what I'm going to be talking about is a specific pattern here, or a specific group of patterns that help enforce some of this. But the traditional view of microservices, you do your domain-driven design, you get your domain objects, and you build services around those domain objects, and those domain objects create separation by their very nature. That does mean you get responsibility, single responsibility, and a very, very good deployment boundary, and that's the opposite of that monolithic data access layer, if you think about that. So an ability to actually just revise individual services without impacting the delivery of other services. And the key aspects there is the last one there, which is the best skills for each service. It may well be that you want to use a NoSQL database for one service, accessing it via C#. It may be you want to use Mongo for another service, accessing via JavaScript, for instance, and so on. So you get to pick and choose the services, the skills that you need. The one thing I will add to that is the best skills for each service may not necessarily be the best technology choices. It may actually be the best skills, in that case, are the skills that you currently have in your organization. So that allows you to deliver these things much more quickly, of course. Now, of course, the downside of that is you do have a much higher degree or need to have orchestration between those services, in the sense of either things calling into their individual services and bringing them together, or indeed the last point there really is around transactions, which we'll get to in a little bit. But it does mean that when you've got all these services that are talking to their own data services themselves, you do wind up with a potential issue of things going out of consistency. So the state of the overall system is hard to manage. And of course, one of the aspects of that is that you don't have that traditional ability to have a business process that's calling many different types of objects and is creating a transaction boundary around those objects so you can compensate, because all these things are running separately. So how do you deal with that transactionality that you would normally have through a traditional ORM data access layer? So these are all challenges, I suppose, that you could call them, challenges that you have to overcome when you implement a typical microservices architecture. So the way that I'm going to talk about overcoming that is essentially through event-driven design. So if you remember the previous diagram, I had a service calling other services, and of course you can absolutely still do that. But of course, if you do that and you have services calling other services, then you still wind up with your more traditional spaghetti architecture. So you may have a service that writes something to an order table or an order database, and then that service itself can orchestrate through some other process to an inventory process to take information off or take stock off the shelf. But of course, that may also then have to go to fulfillment and the invoice service, as you can see there. So there's a lot of orchestration that you need to do, or a lot of design that you need to do and understand in order to overcome those problems. The flip side of that, of course, is to have something right in the middle, which is an event service, which actually just does all the shuffling around of your data itself. So there we are. So that's essentially what I'll be talking about today, the event-driven design approach to building microservices. Just like service-oriented architecture and a lot of other things, key patterns have evolved. I mean, I don't know about anybody else, but I have on my shelf here the book Enterprise Integration Patterns, which I've had for many, many years, and I've read cover to cover over the years. And again, that just highlights key architectural patterns that you may use when you're doing typical integration scenarios. In a similar way, from a microservices perspective, key patterns have begun to emerge, and I'd certainly urge you to go to Chris Richardson's website, microservices.io, where he has a great deal of patterns that you can just pick and choose from and use as you need. Now, for the purpose of what I'm going to be talking about today, I chose 3 of those patterns because they're the patterns that were most directly relevant to the scenario that I'm going to talk about. The first one is a database per service. You can probably guess what that's about. The second one is Saga, and the third one is called transactional outbox. Excuse me. So let's just start digging into those. So the name probably gives a clue as to what database per service means. It is essentially, I suppose, what you would call that traditional look and feel of a microservices architecture. So you'll have an individual data store for each individual service. So that's really sort of that whole breakdown of the domain. The good thing about that, of course, is you choose the language and, in fact, the data store that you want for each time you create your service. Another key aspect of that is you may have one service. For instance, you may have a customer service, which doesn't change very often, but you may have an order service which changes or has updates and additions very often, and you want to be able to scale those completely separately because the load and the requirements of each one of those and the management of each one of those is very different. So when you have that deployment and management lifecycle and needs that require them to be separate, this is a great pattern for doing that. Downside, of course, as you can see here, just as this example, an order service and a customer service, is it does increase the complexity for the consumer of the queries. So think about that. If you've got a UI, there's no layer above this, so you can have an API gateway that aggregates this information, or you're essentially on the hook for bringing this data, calling multiple services, bringing this data together and displaying it as you see fit. And of course, the other thing is cross-database queries aren't very easy to do. So if you have an ID, customer ID in one table and a customer ID in the other table, you can't readily join these tables because they are actually completely separate data stores. So you can't just do a join between them. So you have to think about how you might do that, how you might aggregate that data and use appropriate tools to do so. The next thing I'm going to talk about, just one second. Quick drink. The next thing I'm going to talk about is what is called the Saga pattern. Now, Chris actually describes 2 versions of the Saga pattern. One is this choreography-based Saga, and the other one is the orchestration Saga. Whilst I'm going to be talking about this particular one, the orchestration one is also quite a useful one. So that has essentially a service which has, as part of that service, an on and off ramp to, say, a message channel. And what that service then does is it publishes messages and consumes messages off that channel, off that messaging bus channel, so as it can communicate with other services. So essentially in that scenario, the communication and everything to do with the communication in and out of services still lives inside the service. It may be orchestrated through a message bus, but it still lives inside the service. So you can imagine that if you're having to onboard new services, there is still a degree of coupling involved in that. What I liked about this choreography-based Saga is that actually it's just using events. So the services act completely separately and just publish events onto that event channel that we saw before. So what I called the event service. But of course, the outcome of that, and it's the outcome that we keep talking about, is that because these services have no knowledge of each other, what happens is that you have no transactional control across the entire estate of your service architecture. So how do you overcome the fact that you don't have transactional control? Are there mechanisms by which you can solve that problem? Well, Chris on his Microservices website actually describes two key ways of overcoming that. One of which is event sourcing, which is something which I won't specifically talk about today, but is a fairly traditional way and is used quite heavily in the architectural pattern CQRS, and essentially allows you to just have a forward-only read of the events, and when you want to find out what the state of a particular service is or particular object is, you just read through those events. But of course, you are then on the hook for making sure that those that table which represents those events gets cleared out on occasion or gets consolidated, because otherwise you just wind up with a very, very long list of events that you have to read through, and that list of events gets longer every day. So the one that I'm going to be talking about is in fact called the transactional outbox. So I mentioned here about the fact that it's useful when there's no two-phase commit possible. Essentially what we're doing here is we have data sources that are completely decoupled, so we can't have transactional control across them unless we force that into the service layer and then have all kinds of compensation mechanisms built into the service layer, which of course just is creating just another monolith. So the way that this works is essentially in your data source, you may have an outbox table as it's described here. The reason I chose this pattern will become obvious when I'm talking about Cosmos DB. But essentially what you do is you write things into some forward-only log, and then something reads that log and publishes those events to some third-party broker, which can then distribute those to parties and services that really, really care about that. So that message broker there, as you can see on the right-hand side of that diagram, really very much is a publish and subscribe broker. So we'll talk about just the things that I'm going to be implementing just very quickly. We're all integration people, so I guess we probably know some of these details fairly well anyway. So Azure Functions is about code and events, and I specifically asked a friend of mine to forward me this because I saw this particular animation a couple of years ago, and I think it just indicates quite well why it's why the Azure Functions logo is what it is. Because if you take code and you take events and you mash them together, then that's exactly what you get. So think about functions. We have, so let's just go to the next screen. We have a serverless compute. So it's well, in the sense that anything is serverless. It's a pay-per execution model if you want to go that way. There is a premium version of the service which has a single instance of your service or your function running at all times, so you eliminate that cold start potential that you may have. Why is that important? It's important because if you have a cold start and you have a service that is very, very reliant on a very, very low latency response, that cold start can cause timeouts. So having that premium plan allows you to eliminate that. The next bit up from that is, of course, the application service environment, where essentially you're creating your own app service and running the functions inside that app service, and you are able to scale as you see fit, and you're responsible for the life cycle of that app service. And the last one there is the Docker container. Of course, everything is being pushed to Docker ultimately, but things will remain obviously as platform as a service in Azure for a very long time. But there is also the ability to run Azure Functions in a Docker container, and that's useful for when you're doing things like running stuff on the edge compute. But overwhelmingly, and the reason why this is important in the context of microservices, is that actually Azure Functions is an event-based architecture. It is based on triggers, rather like Logic Apps and some of the other things that we'll be talking about very shortly. So in the context of what I'm talking about today, the key things there is an event grid trigger, a Cosmos DB trigger, and a HTTP trigger. But there are lots and lots of others. And obviously, if you've used functions, you'll know about this. But if you haven't, I definitely urge you to go and have a look at an investigation of Azure Functions. They're pretty feature rich. When you have an event, you can also have an input binding. I haven't mentioned those specifically. So an event can happen and it can trigger an input binding, which can be a read of something, for instance. That will be relevant for this particular scenario. But you also have output bindings. So the key one that I'll be talking about today is Cosmos DB. The one that isn't currently available, even though I need to use it in my scenario, is an event grid output binding. So when you want to push things out to event grid, you actually have to create your event manually and use the client itself to send it out. You can't use an output binding because that doesn't currently exist in Azure Functions. And going back to that point that we were talking about the best tool for the job and the best database and the best language, of course, Azure Functions does support a bunch of languages, and those are highlighted there. So C#, Python, and JavaScript I'll be talking about today, but it does also support PowerShell and Java. So Event Grid is a reactive programming model. So essentially you have a bunch of sources and a bunch of handlers, as you can see, and in the middle Event Grid. Event Grid is true publish subscribe, and the key thing here really is that it's push, not pull. So you don't have, for instance, like you may have on Logic Apps with a SharePoint document library, where you have to check every now and again, see if it's there, and every time you execute that to see if it's there, you're getting charged. And when you get in charge and there's nothing there, you feel very upset, or maybe you don't. But essentially, this allows you to push data to things that really care. It's based on HTTP, so webhooks is a huge part of this. And you can see here webhooks anything at the bottom, and it says other services and applications. But the reason I point out that it's based on HTTP is because there is a key aspect to that when it comes to the event grid binding, input binding, or trigger binding rather, in Azure Functions. If you're using HTTP binding, which you absolutely can do for Event Grid coming into, say, Azure Functions, you can have Event Grid publish something to a webhook, which is exposed as an HTTP endpoint. If you do that with Event Grid, the first thing that you have to do is validate that you own that service. So there is a validation step that you have to do, which is essentially a validation handshake, which says, yes, I own this service, so please accept that I can onboard events from you. If you use the Event Grid binding, you don't have to do that. So that's a key thing that we'll talk about when we go through this. When messages come through or events come through, obviously you may want to filter things out. There's fairly strong filtering functionality within the framework. It's very, very quick, very highly available, and you can see some fairly large numbers there in terms of the events per second, subscriptions per region, and the publisher latency. And then there's a 24-hour retry with exponential backoffs for events that are not delivered. But of course, what that implies is that events may not be delivered. So in the grand context of anything to do with when you're building stuff on serverless functionality, or when you're building stuff on platform as a service, generally, when you build things for a cloud solution, you have to build with failure in mind. So just bear that in mind, that when you build things out using things like Event Grid, if something fails, or if the event is not read, then there is a mechanism that Event Grid uses, which is essentially dead lettering. But that means that the thing that is consuming those messages, or consuming those events, beg your pardon, has to find a way of then reading that so as it can then move forward and understand those events. That's if those events are important. But the key point there is events inside Event Grid are ephemeral. They do disappear, albeit onto a dead letter, but they do disappear. So you just need to be aware of that and make sure that you're building your solution to take account of that. And the last thing I'm going to talk about before we get into the demo is Cosmos DB. So ordinarily, if this was a more interactive session, I'd ask people to put their hands up as to who's used Cosmos DB, but I probably won't be able to see you, so that's not going to work. But essentially, Cosmos DB is it's a NoSQL database. It currently supports those things at the top, although not fully in some cases. I'm going to be talking about the SQL API today and the Mongo API. But essentially what you have is a data storage mechanism that is exposed through a bunch of APIs that you can use through the various SDKs that are supported. So the key other points there really is that, as you can see, it's globally distributed. So you're able to just write stuff down and have it automatically distributed to various global locations in various different data centers. So from a scalability perspective, if you're building a very large scale architecture with services deployed in lots of regions, if you need that data to be available in all those regions, then Cosmos DB is a great tool because it allows you to just write once and it will publish to many, many locations. It's multi-master, rather like SQL DB. So there's a quorum of servers. And because of that, it allows you to have different degrees of consistency. So the strongest consistency, if you like, is that all of those servers have to report back that they have committed that transaction or committed that data right to the database or update before that change becomes publicly available. So you don't ever get dirty reads. The other end of that scale, and it is a scale, there's a continuum, there's many different states that you can use, is eventual consistency. So you write to a single server, and that server will then push that out to the quorum. And if you just happen to read something from one of the quorums that's not been updated yet, then you'll get old data. So just bear in mind that that's an important aspect of that, because it does impact how you read and write, and you just need to be careful about how you do that when you build a solution based on Cosmos DB. One of the new things that's still in preview, I believe, is that there is actually Apache Spark built into the top level of Cosmos DB now, so you can actually perform fairly large grade analytics inside Cosmos DB on the fly now. So that's a good little tool. Now, remember we talked about the transactional outbox, the ability to have that table which is logging the events that are happening inside your data source. Well, the reason I chose Cosmos DB for this particular presentation is it has one essentially by default, which is the change feed. So the change feed is a forward-only log that stuff gets written to, and it is only, and I'll show you updates or inserts and updates. It doesn't support deletes yet, but it is a forward-only log, and when that forward-only log gets written to, you can process the data out of that forward-only log as you see fit. It's essentially a stream, so think of it very similar to something like Event Hub, where you have an ability to wind forwards or wind backwards in time if you so desire. That does introduce some challenges, which I'll get to in the demo. There is currently no support for Event Grid, so if you want to process data that goes or that is written, updated, or deleted from Cosmos DB, currently change feed is the only way that you can do that. When I say deleted, as I say, it doesn't support delete. The change feed doesn't support delete currently, but obviously if you have a record and you've got a delete flag on there and the record is deleted, then you can update that flag. That indicates an update, and then you can process that update. So you can overcome the fact that it doesn't support deletes by just having an actual delete flag on the record itself. And if you're very precious about keeping space and everything sorted out, then obviously you can have another process which then deletes those records, because that won't write to the change feed anyway. It's ordered, so the key thing there is that it is ordered to a degree. So if something gets written to the change feed and you don't process it, the next write to that record or the next update to that record will actually overwrite that previous change. So it's ordered, but it only keeps the latest instance of the particular update. So it's probably pretty important, if you need to do so, it's probably pretty important to have that as a reference that you can then go back and get the record, say, or it may well be that you want to have something that triggers on every single change feed updates, which is of course where Azure Functions comes in. So the demo I'm going to talk about is order fulfillment. So I'm going to start with an API, which is going to publish a record to, actually in this case, MongoDB, because the cart is MongoDB. I'm going to update that, and what that will do is that will publish an event to Event Grid. The order service will be listening for those events and will update a record or write, sorry, beg your pardon, we'll write a record into Cosmos DB. So of course, we know that when we write records into Cosmos DB, in this case, it's the SQL API, and that's important, that triggers the change feed. So that record being written to Cosmos DB will create a record in the change feed. So of course, that gets read, and we publish. Which doesn't really do very much apart from publish an event, which that is then read by another order service. And at that point, we update that Cosmos DB record for that order. And of course, we know that the change feed works on updates or insertions and updates. So that will fire another service, which will create another event grid service, event, and then we'll finish with another service that will read that. Now, that looks fairly long-winded, but there's a reason behind this, because I want to show the ability of all these services being able to use multiple languages with the different SDKs that are available. So let's jump straight into that. First off, I want to just go through the Cosmos DB trigger, because I just want to have a very quick look as to the way this works. So we'll see here we've got, this is just an Azure function inside obviously Visual Studio Code. So I've got a Cosmos DB trigger, I've got a database name, I've got a collection, I've got a connection string, of course, and I've got this thing called lease collection. So what that lease is, think about the lease collection. If you've done anything with Event Hub in the past, you know that Event Hub has a consumer group. That consumer group can be read by multiple services, but of course, every time something draws something off that particular Event Hub, that consumer group just makes sure that it knows where you are. So essentially checkpoints as it goes along. Think about that. That's essentially what this lease is doing. So if we just start this up, let's just let that start, and we'll go over here. So you'll see I've got this this dummy collection inside a SQL API Cosmos DB database here. And I'll just click this to make sure that there's nothing here, because I think I did delete it earlier on. It did. Right, so let's just make sure this is up and running. And it is. Fantastic. So if we go in here now, remember it allows you to, or it picks up, the change feed picks up both reads and writes, writes and updates. So we just very quickly go in here and just save that. That's then saved. And we'll see that trigger 1 is fired. So we can see that this is indeed reading that particular process. If we were to go and actually add another function, so let's create a new function. We'll have Cosmos DB, we'll call it that, and we'll use that, and we'll call it dummy and dummy. And it'll just go away and do that. And whilst it's doing that, let me just copy this piece of code. Just to put that in there. Stop that. That's trigger 2. So if we restart this now, let's get rid of that. When we go into our record here, of course, we can update this, because an update will also trigger a change feed. So let me just change that to Bill. We'll just wait for this to come up and run. Here we go. It's nearly there. Okay, right. So the application started and we're ready to roll. So if I now go in here and I save this record, let's update. And come back to our code. Let's just let this fire. And my God's be kind. There we are. Then you'll see it's fired trigger 1, but it's now saying that there's unhealthiness detected. Now, rather jokingly, I saw that first time and I thought to myself, hang on, how does it know about my eating and drinking habits? But obviously it's actually talking about the service itself, and you can see it's saying in operation acquire lease. And the reason that that's happening is because actually what we're doing here is we're using the same lease for 2 different services. And that's a very key point. So going back to that point I was making about consumer groups, essentially the way to overcome this is if we put in a lease collection prefix equals 1, and then in this one we'll put in the other one. Again. So now what we're doing is we're having completely separate lease collections for these. So these services can now truly act completely independently from each other rather than stepping on each other's toes. Now it may well be, and you can see there it's fired and it's picked up the previous one actually. So and then you can see this fired both those services just to prove that that's not made up. I can go in here and change this to, I don't know, John. Update. Oops. And we can see it's fired both those. So you can see that rather like you have separate consumer groups to make sure that Event Hub processors process separate data, you do the same here. So it's very key to make sure you do that. What I've also got here is an event grid trigger. So this event grid trigger is essentially just a proof, just to prove that we are all working. So this is running locally, and in order to overcome the fact that this is running locally, if you use a little tool called ngrok, so that's this thing here. I've got 3 instances, which will become clear as to why I've got those 3 instances. ngrok essentially takes your local host and exposes it to the internet via their service, which means you can then call it. And you notice it's exposed as HTTPS. So going back to my point about event grid being HTTP based, that probably just tells you what you need to do, you need to know. But you'll see here that with this event grid trigger, what I'm not doing is having to go through that validation step. So if you look up validating event grid in the Microsoft Docs, you'll see that you have to do a little validation handshake when you first onboard a service. The event grid trigger does that for me, so I don't have to worry about that. So if we go into my window here, yeah, right. So let me just reconnect my Cloud Shell. So here's a dummy topic that I created earlier. So what I'm going to do is I'm going to create a new subscription so that when I post something to this event topic, it sends that message onto the service that I've got on my laptop. So I'm just going to grab this value here because I'm going to need it. So I'm going to create a new one. I'm going to call it dummy topic. Sorry, dummy sub. You'll see here that event grid supports 2 types of schema. It supports 3 if you included the input one, but the basic one says they're an internal schema, but one that's called Cloud Event Schema, which is a schema which has been published to the Cloud Native Foundation. Word of warning, if you want to use the event grid trigger, you can't use Cloud Event Schema because the event grid trigger only supports the event grid schema. We can filter on event type if we so desire. And we can also filter on some information that's within those events, either the subject, so an event has a type and a subject, or some data that's within the payload. But what we're going to do is we're going to say that we want to create a webhook. So let's put that in there. So you see here that the webhook is the HTTP address, webhooks, event grid, and then the function name. So that's the way that you create the webhook. So I'm just going to go down here and click OK and create. Now, because my service is still running, this or my functions, Azure functions are still running, this will complete. So ngrok can be running, but if your Azure function is not running, then event grid can't create a subscription because it doesn't know where it is. So I'm hoping this still has stuff in here. So let's just make sure it does. Okay, cool. So what I'm doing is I'm going to create a message through the Azure CLI through the Cloud Shell. So I'm going to create an endpoint. I've already got something called topic. Hang on, let me just set my. It's gone to sleep, so I need to set my account correctly, and then we're going to set my endpoint. So that endpoint exists inside this particular subscription. You can see it's called dummy topic, and you can see that at the top there. I'm going to grab the key that is part of that. And then I'm going to create some data, which I'm going to post to that endpoint. So you can see here, that's just a random ID. That's the event grid type, or the event type dummy. You see the subject. So remember, we could also filter on that, and then some data. And then because, of course, this is HTTP, I'm going to just post that to the endpoint that is the topic. And what we're hoping is that as a result of posting to that topic, it will publish that event to the subscription that I just created, which is a service running on my machine. There we go, it's published it, and we can see it's come in here and it's stopped, and we can see that it's processed that event. And if we really want to, we can have a look at the data. There it is. You can see some information about that particular data that's coming through. So you can see that that's how it's all wired up. So we can see that the Cosmos DB trigger works through that change feed, and the event grid trigger works through those subscriptions. So if we actually go to our proper scenario now, we'll just move things on here. So I just want to show that there's no smoke and mirrors here. So I have a MongoDB, which is my cart, my shopping cart, and there's no documents in there currently. Oops, let me just minimize that or move it, perhaps. Move this, yes, okay, good. I have nothing in my orders table, which is the other part of the process. This is that website just very quickly, the microservices.io website. It's very, very good. I certainly urge you to go there and have a look. What I have here is I have 3 projects, one in C#, one in JavaScript, and one in Python. So my Python project is, just move that back over here. My Python project is a very, very simple service. It's an event grid service that's just going to process, or it's going to react to something. And then these other services are doing various things, which we'll talk through as we go through. So let me just start all these up. So if we go to the checkout cart one first, because that's the first one that's going to fire, we can see here that it's using HTTP trigger. That's fine, it's all good. That's what we're doing. And I'm creating an event grid message. So this is how we create one. We create a list of records or a list of events, which is the way that event grid works. So you publish a list of events. You can see here, this is the subject. This is the order. This is the event type. So those are the 2 things that I can filter on. Of course, I can filter on some of the top data as well. And then we set our various parameters around the endpoint and the key, and then we can publish that group of events. This is how we react to an event grid trigger. Of course, we saw that. And here we're also using the Cosmos DB output binding. So the output binding obviously is where we're going to send stuff to Cosmos DB, and that should trigger something in the change feed. I think these are all up and running now. And then we've got some more stuff around Cosmos DB. So this is a Cosmos DB trigger, and then so another event grid trigger. So if we just look at our scenario, we'll go into Postman here. So what I've got is I've got a catalog. So we'll just get a reread of that catalog. It's a very, very simple catalog. I've got 2 pairs of running shoes in there, some Nike Air Max and some Adidas Los Angeles. Those are my 2 favorite running shoes of all time. We can have a separate discussion about why that might be at some point. But I've got an orders table. You saw that that didn't contain anything. And I'm creating a cart. So here I've got a cart ID, some information. I'm going to make it in progress. And I'm taking, 1 pair of size 8 Nike Air Max and 2 pairs of size 7 Adidas Los Angeles. That's kind of irrelevant. But what I'm going to do is I'm going to publish that to my cart. Hopefully we'll see a 200 come back here. Yes, we do. So if we go to my MongoDB here, we should see now that we have a record. And here we are. So there's my MongoDB record. Now, the next thing that I'm going to do is update that record. And if we remember, I'm going to then create an event, right? So if I go to my checkout cart, I'm going to update that. So at the moment, all I've done is created a single HTTP request to the cart service, and everything else will flow based on events in this particular scenario. So we go in here and we can see that I'm in my checkout cart because it's that trigger. And I'm going to go down here and I'm going to create this event grid record. So let's just F5 through this. That's now coming to the order service. So all of these services are in this particular project because I wanted to keep all my C# services in a single project. But of course, if you were doing this for real, you'd separate these into separate projects from a deployment boundary perspective. So I'm now going to create a record in Cosmos DB for this particular order. So we can see that that's gone into my Cosmos DB trigger here, and I've gone in here, and there's an order status pending. Now I could have filtered that based on some setting in either the event type or the event subject, but I thought I'd do it this way, this particular case. We'll also see that it's gone into my JavaScript project because it's also listening to that event feed. But what I'm going to do here is if I press F10 here, the order status isn't in fact accepted, it's pending, so it's stepped over that. So we go back to this service here and we click through here. It's gone into my pending, and that's now going to create an event grid event, which is then going to trigger my payment process, which is another JavaScript service. This is then going to create another record. So this is just how you do that. Also another event grid event. This is how you just do that in that particular service. Back into my order process. This is now accepted because this is an event grid record. This is now accepted. So I can go through here. So this particular service updates my record inside Cosmos DB. So of course that creates a change feed change. So again, that fires in both the C# record I've got pending here. So if I F5 that, we'll see that it finishes and doesn't run. If we go in here and we just F10 this, we'll see it comes in here, and that's now going to create another service, another event grid event. And the final part of this puzzle was to do that fulfillment service. And the reason why this is in three separate projects is because this is actually in Python. So this is how you process a particular event in Python. So you can see that all these things are in separate services or in separate types of separate languages, separate databases as well. We've got Cosmos DB SQL, Cosmos DB Mongo, and obviously this particular one doesn't do anything. But you can see that essentially what I did there was I just created a single HTTP request, and it's updated or triggered a bunch of events that went through my entire service architecture to update a record and then create various other things beyond the back of that. So we'll just go back to the slides just very quickly now because I'm conscious of nearly running out of time. So let me just go through here. Right. So what I've shown is just fairly bog standard code. What I haven't talked about is security. So you don't, as is traditional in all these things, you keep your non-functional requirements until last. Please don't do that. But essentially what I've not done here is security. Well, all these things are secure by default, of course. So my functions can be secure. My database is secure anyway, and an event grid requires that key to call it and that validation process from an HTTP perspective to react to it. I'm not doing any telemetry or monitoring on this. Of course, you absolutely want to do that. If you don't know what's happening inside your application, you don't know what's going on, and then you've probably not done a great job of building that application. I haven't used APIM in front of my particular services, although you can do, of course, and that provides other authentication mechanisms. I don't really have exception handling and how to cope with downstream events, so things like services not being there. But that then leads to the next point, which is robust eventing and routing. So you do need to deal with not only that exponential backoff and how you deal with deletions of those ephemeral or dead lettering, big one, of those ephemeral events, but what happens when you have triggers that don't fire. There is a premium tier to avoid that cold start. That's pretty important. And the nice thing about the last thing is, of course, we're all talking about DevOps nowadays. Because you have those deployment boundaries, you also have the ability to have CI/CD specific, and the application lifecycle of those services can be completely separate to each other. Key takeaways now. So I've talked about all these things, but the change feed trigger and the input binding and the output bindings only work with the SQL API currently inside Cosmos DB. So if you want to use Mongo, then you have to do things a different way. You have to create an event and use that event via an event grid trigger to then process data. We mentioned about the fact that the change feed doesn't support deletes. That's quite important. So you need to do that differently. I mentioned this, event grid binding only works with event grid events, not cloud events. So if you want to use cloud events to make sure you're nice and standardized, then you need to just fall back on that HTTP trigger rather than using the event grid trigger binding that's directly in functions. whilst I've talked about the fact that all this stuff is just message passing, and you know, overwhelmingly what I have done is I've passed the content of each event has been the actual message itself. That sounds like messaging, I know. What you can do, of course, is just pass a reference to that event, and then that service can be responsible for going back to the original service to get that data. That's kind of probably more that orchestration-based process. Is a combination of that orchestration-based and choreography-based sagas. So there's that option available as well. Sometimes a monolith, or at least the impression of a monolith, is the answer. If you're the mind to do so, look up Tom Kirkover's presentation at Ignite. It's a very good presentation around exactly that subject. Sometimes a monolith is the answer. So that was Ignite 2019. You do add complexity. Microservices architecture just adds complexity all over the place. It genuinely does, but the complexity is a trade-off, and what you get is that agility and the options for future-proofing your solution. And with that, I think I'm about 2 minutes over, so I shall just, there's a resources slide. I'll be providing all these slides, and you've got the video anyway, so I'll be providing these slides to Bill for him to post as well. And with that, I'd just like to say thank you for attending, and I'd like to say thank you for Bill for organising such a great online event. Thank you.
Thank you very much, Martin. So, any questions? Okay, so what we'll do is drop out of this meeting, and I will be back shortly to do the last session. I will apologize now. I'm going to try to play with this nice little cute box that I've got. So if it takes me a little longer to get back, just bear with me. But thank you very much for everyone so far, and I will be back shortly.